So finding, accessing and working with LiDAR data. So we're going to be having a look at what LiDAR data is available for New Zealand. I'm going to be grilling these guys about, in a nice way, about the difference between DSMs and DEMs and LAS versus LAS and other things. Then I'm going to have a crack at showing you, for those of you who are still new to working with this data from the LINS website and others, how to download and process some elevation data. So if anyone would like the area used as a demo, just to show that this is live and real, put a place name in the chat and we'll use that as the demo. Rose is going to show us a few to-dos with Open Topo. And then we're going to hear from John about some real-world experience from a real-world practitioner out there in the real world. So thanks for coming, John. And we're all in the real world, but John's more real than us. He exists. And I'll shut up now. And then Rose is going to show us a few neat tips and tricks and tools. And then once we've plowed through that, we'll go through as quick as we can. It'll be recorded as well, so you can watch it later. We'll have time for some Q&A.
Okay, cool. So the agenda here is finding, accessing, and using LiDAR data. I thought I would just cover off the first two are actually dead easy for the data that LINS puts out. I would like to cover that off before handing it over to Rose and John for doing the heavy lifting on actually using the LiDAR data. So just how does one discover or find the national LiDAR data that LINS curates and puts out? I'm just going to go straight to a web browser, simply do a search on New Zealand elevation. If you just type in New Zealand elevation, this should get you there. New Zealand LiDAR would do the same thing. If we scroll down, if this works right, the top hit is, the second to the top hit is elevation data and information for New Zealand. So that's the link I will start with. The top one takes you to the LINS data service. So it's pretty easy to find just through your regular search bar. This takes us to our elevation landing page, which describes the National Elevation Program for LINS. I'd like to start with a static map that we display. While it's static, we update it roughly monthly as the national picture changes. It shows the LiDAR availability for New Zealand. Everything in green is data that is openly available. So open meaning open license, free to access and use, no restrictions on it. Orange is work in progress, and the cross-hatched orange is through the very large-scale provincial growth fund project that LINS and 8 councils are partnering on right now. So as data becomes available, it goes from orange to green. The nature of LiDAR is very hard to give accurate dates on it, but when we do, we have a table below when we show the estimated availability. I'd like to just say a couple of words on going from the process to go from green to orange. When we receive a data set, we curate it. This is a large part of the work that Rose does. It means checking the quality of the data, often editing it, and to ensure that when we publish it, we are putting out consistent and high quality data. For example, everything that we publish is consistent file naming, consistent tiling, all relative to the New Zealand 2016 vertical datum. So then going on to how to actually access the data, we provide 2 links here for the raster products, the DEM and the DSM, so the bare earth digital elevation model and the highest feature digital surface model. You get them from the LINS data service. There's a tab here, click on that, and up comes the LDS webpage where you can then further access the data and Just zoom out on the map. Okay, anyway, so that shows all the raster data holdings that you can then freely download from the LINS data service. If we go back to our landing page, if you're interested in the point clouds, we distribute those from Open Topography. So again, there's a link to the Open Topo website taking a New Zealand-centric view of the data. So this lists the individual data sets. And if we scroll up again, there is a map showing the bounding boxes for the data sets which are available for download. So that's discovering and accessing the data.
Awesome. Thanks, Bjorn. If anyone has any questions for Bjorn, he'll be with us to the end of the session. So I'm going to leave my microphone off and just talk loudly so it comes into Rose's one. Now, Rose, have you got everything set up there that you need?
I do. I'll just do just said we again, a quick run through of everything.
Okay.
Sorry guys. So.
And I'm going to ask you the big hard question in a moment.
You?
Yeah.
I'm being too quiet, not close enough to the microphone.
Okay.
Apologies.
Right, keep it out of your face. Okay. Yeah, get rid of that guy. So Rose is going to, what's Rose going to do? Rose is going to show us some stuff. Difference between a DEM and a DSM. She's just having some issues finding my login at the moment.
Sorry about that. There we go.
There we go. Press some. Yeah.
Oh, I don't want to share personal emails. Yep, awesome.
Okay. Rose, can you tell me, them, the people, the difference between a DM and a DSM? Because I know when we did our webinar this time last year,
Yep.
it took me a while. I had to ask you a few times because this was a new thing for me. So can you tell us the difference between a DM and a DSM?
So a DEM is an acronym for a digital surface model. It represents the ground elevation of the area that is being flown over. The DSM stands for a digital surface model, which represents the highest feature found on the ground. So usually for DEM, you'd find the bare earth model. So that's another word for a DEM, bare earth. So if you want to know the heights of grounds beneath vegetation, you would look at a digital elevation model. If you wanted to visualize Wellington City, for example, you'd look at a digital surface model in a raster.
Cool. Thanks, man. And next question for you. They also talk about LAS, ZLAS, and a whole bunch of other different formats and things. Can you maybe show us or tell us what's the difference between these different formats and which one should we look out for?
So the main format for 3D point cloud data, so for example, if we want to find data that looks like this, the main format it comes in would be an LAS format. It's a really well-developed specification documentation. The LAZ format is just a compressed version of LAS. They're both open source. The LAZ format is 5 to 8 times smaller. It's very handy if you're dealing with terabytes of LiDAR data. We do deal with XYZ formats and ZLAS format, which is the ARC proprietary format. So yeah, just bits and pieces depending on what you want to use it for.
Okay, cool.
I'll just go back to the story map, just showing that's a digital elevation model. Just one of the handy things you can do with elevation models is unveil faults. This is one of Irishman Creek fault in the Mackenzie Basin, and so the power of a digital elevation model is you can unveil geomorphological features and fluvial features on the ground, and digital surface model gives you a 3D digital twin of the area that you're interested in. So yeah, the story map. So we'll give out an info sheet of all the LiDAR bits and pieces that we show. So yeah, that's me.
Cool, thanks, Rose. That's a pretty neat.
Oh, sorry, this is just another example. Sorry, Dwayne. Of a 8-meter digital elevation model with the whole of New Zealand extracted from 20-meter contours. So it's very inaccurate. And then if we use our LiDAR data, we really can show this is a digital elevation model, so it's ground elevations only. Really shows which areas you might not want to build a house, maybe. So yeah, sorry about that.
Okay, so my DM that I'm going to do for my demo coming up next is still just downloading. So actually, it's ready now. Okay, so I will we'll swap over. Rose, if you could just mute that side.
Yep.
That's an awesome thing there. I am just going to.
No, I don't want to leave the meeting.
Just mute.
Mute.
Oh, we're both on mute. Well, that's fine. Now we're good. Okay, and I'm going to turn my camera on. So now comes for the chaos. It begins. Live demo time. Okay. I'm just going to share my screen here. So this is what's in all live using Lynn's data service to access some of this data that we're talking about. Let's go hide. I'm just hiding that. Okay, so we had a query there for using some data for Taranaki. Now we haven't got any data for Taranaki just yet. Let me just make sure am I sharing my screen? Okay, you can't see me yet. Where are we going? Hang on. Let me just, oh, yep, pretty sure we are. Just go on the chat, just make sure you can see. Should be able to see my screen. Yep, cool. Awesome. Thanks, guys. Okay, so the request was for Taranaki, but we didn't have any there just yet. Good question, actually. Any ETA on where we might have some for there beyond? Off the top of your head? Yeah. Just if you can share it, is it like this year, next year, couple of years?
I cannot put the date on it. There is some LiDAR data held by the councils in the region. Does not hold any.
Just unmute there, Bjorn. Yep. Just over here. Yep.
Okay, I will start again now that I'm no longer muted. So the question was, do we have data for Taranaki? And if not, when may we have some? So Lynn's does not hold any LiDAR elevation data for the Taranaki region. The council does have some. It has not been loaded into the Lynn's data service or open topography. We are currently working with the regional and district councils of Taranaki on the Provincial Growth Fund in partnership to capture data in the region. You may have heard there was a request for tender that went out that has just closed. We are in the proposal evaluation stage at this point, meaning that work is still has not commenced, but it is in the pipeline, and we will see how that process plays out to know the extent of coverage and when, and the timeline and such. So fingers crossed that is coming.
Bjorn, I have a couple more questions for you here. what can be done? This one's from Peter. What can be done to help local councils, brackets, Waikato, Hawke's Bay and others, to use the LINS portal to openly share LiDAR data they store in their premises? They provide their data for free, but they charge, maybe they use a much, it's much less convenient. They put it onto an FTP site. Is that a question you can talk to, or do we pass that one over to Jonathan to come back to them and maybe share the results?
I can talk to that. When I was showing the map earlier of the data we hold and what's in the pipeline, our aspiration is to be able to host 100% national coverage, certainly of the bare earth that Rose talked about, given that that product doesn't age that quickly. We've been for the last several years working with most councils on getting copies of their data, getting it normalized into that NZVD 2016 vertical datum and a few other things. So it's a consistent user experience, and publishing it through the LINS data service and open topography. So that is our aim, to have a one-stop shop for national LiDAR data. Now we haven't caught everything. We've had to triage a bit, given what our resources are, gone for the largest data sets first, and also the ones that meet our minimum quality requirements. There's some data out there that's just so old and from the early days that we did not want to be hosting that data. So we are open to taking copies of the council data, and they can certainly get in touch with us on that. We do not charge for the hosting. There is an email link on the National Elevation webpage that I showed. We are also keen to talk with councils about filling the white space with other partnerships outside of that large scale provincial growth fund work that we are doing. And for example, we just are working with the Whanganui District Council on getting a LiDAR data set there, which fills a gap along the coast of the Horizons coast.
Okay, cool. Thanks, Bjorn.
Yep.
So just stay there, Matt. The two microphone thingy is not working so great. So I'm going to just check. So leave that one now. We'll just keep with the one microphone. Okay. Just checking. Can you hear me now? Thank you. Fantastic. We're just going to use this one microphone, the better one. Hopefully it's not hiding me. Can't see myself. That's fine. Okay. What we're going to do now is a really quick demo, because with these sessions, I really wanted to make sure that we're not giving PowerPoints. We're just showing you things that we all think are neat and that we use every day. So for me, one of the most common things that I do is I'm a bit of an end user hacker. Although I sit with these guys and I sort of am a bit in awe of what they do, I'm an end user. So I go there and I grab the data and I do it for a specific purpose. I throw it somewhere and then I'm off. So what I've done is I've downloaded this little sample data area here for Manawatu, which I've not had a look at before. And so here it is in my download. So first thing is I went to the LiDAR index that we go in here. I just wanted to make sure I had that data ready. So I look for the LiDAR index like this. And I think, Bjorn, did you show this one already? Somewhere in here. There's an imagery index or something like that.
I showed the LiDAR index.
Yeah. That's the one. I can't find it in 2 seconds just here, so I'm going to flag it. But then it came up here and I could see that it was LiDAR and it was Whanganui in that batch. And I could see that, okay, there's the tiny wee spot just there. I'm going to add that. And you can see there, because I was looking for something for Taranaki, there was nothing there. But there's a little spot there for Ohura, which looked just fine. And you can see it's going to download the whole data set, which is 8 gigs. So I don't need that. I'm just going to go here and I'm going to go crop. And then I'm just going to go 42 megs, download. I'm going to take the default because I'm not too particularly bothered. You can pick NZTM if you want. You can pick WGS84. You can pick any of these to your heart's content. And I'm going to go for TIFF because if I go for ASCII, you're going to have to do something else to it. So TIFF is just like a bitmap image, like a PNG or a JPEG type. And click accept and create download. And using the magic of doing stuff while Bjorn was talking, I go to my downloads and you can see here, I've got a download there. And here's the file that I've gone and downloaded. So then I go show in folder. And what I should have done is started up my ArcGIS while I'm waiting, just to make sure that I'm logged in. So I've downloaded my file. I'm waiting for my Windows, which doesn't usually not responding. And I'm going to go extract to there. And let's see, where did that go? Somewhere there. Here we are. Here's my files. Now, I've been really lucky, and part of the reason I didn't want to go too involved is there's one step we're not going to have to do, and that is to create a mosaic of one or more tiles. So we can see here straight away, the data that I've downloaded that's the main meat and potatoes right there. Let's see if we can see how big that is uncompressed. 48 megs, so it's not too bad, nice and small. You can see it's an image, it's got dimensions, it's got resolution. This file, the TFW file, contains the georegistry information. The text file is probably a metadata of some kind. The AUX files will make it, that's to do with pyramids and speed of drawing. And the XML is either metadata or something else, I'm not sure, but that's okay because I read all the metadata on the page before I download it, so I know exactly what oh man, I can't remember my password. Okay, we're going to have to come back to me while I figure out what my password is. Because I use that awesome thing from Google. So I'm going to have to go and do Google things to get my password. So Rose, while I'm doing this, would you mind showing us OpenTopo? I'm going to hand this microphone back to you over here. And yep, and there we go, good to go. And just make sure you share your screen. So I'm going to stop sharing here.
Yep, sweet. So using Open Topography, so I'll just start sharing my screen. Okay. So Land Information New Zealand publishes 3 products under elevation data. We talked before about digital elevation model and the surface model. That's a raster derivative of the classified point clouds that we also publish. So to get down to the the classified point clouds that all the rasters come from, extracted from, you can go to Open Topography. I'll just, maybe I can move this toolbar. There we go. Open Topography. And there will be a link that you can click on that we'll provide afterwards, this link. We can filter by locations. So Open Topography publishes American datasets as well as New Zealand datasets. So I'll just filter to our datasets. So if you wanted to download and do your own analysis or create your own digital elevation or surface models, you can go to that site that we were before and just click on whatever you were interested on. So I'll just go back to Wellington City. So Wellington City dataset is our densest LiDAR elevation data published yet through LIMS through the Creative Commons open source license. So once you've clicked on the data set, so there's an option point cloud data that we just clicked on before the blue button. There is this dataset overview page, which gives you a really quick rundown of who funded it, who did we partner with, who collected it, what are the densities, and we just have a couple of URLs just giving you a guidance on how to cite them, more information about the data set itself. Open Topography have developed a really extensive and comprehensive reporting system in terms of what is in these LiDAR data sets, how dense is it, what it contains, and you can also run a PDAL info report on the data, LAS validation report on the data set, and it tells you so much information. So you just go to every single metadata header. You can find out all that information on Open Topography. So long story short, in order to download some awesome 3D data, you can just go to the area you want to download, click on point cloud data, select a region. I'm just going to go down to the Botanic Gardens where we are right now. No, we're not at the Botanic Gardens, but at the terrace.
Kind of wish for it.
Oh, I'm not doing this very well. There we go. So we selected what we're curious about, the region that we want to have a wee nosy. You can also use manual coordinates if you'd like, instead of drag drop boxes. I'd like to exclude noise when I download classified point cloud data, just to make it look cleaner, and it's just a lot quicker and more, it's just easier to see what you're looking at. Unless you want to do really in-depth analysis, you can do whatever you like, just download as much or as little as you want. So the options are just repeating the difference between the LAS and the LAS format. This is a compressed lossless format, so you don't lose any information. So if you storage, you don't have enough storage, that's where it really shows its grunt, if that makes sense. The LAS format is used in both Arc ecosystems and open source, so it's very interoperable. So that's the power of the LAS format, but also it's LiDAR data can be in XYZ format and also ASCII text readable format. So yeah, that's a wee bit bigger. So they all have their own perks, pros and cons, perks and weaknesses. So downloading LiDAR data, you can create your own DEM. Just click on a button, say, do I want it at 1 meter resolution? Do I want it a bit finer? It'd be good just to have a wee investigation of how dense your LiDAR data is in the area that you're curious about before you make the DEMs, just to make sure you won't have a raster with lots of holes in it where there's no points that were in that specific cell location, if that makes sense. Let me know in the chat if anything doesn't make sense, and I'll just stop and hopefully clarify myself. So long story short, you can create your own DEMs. You can also create hill shades. So as Dwayne demoed before, about to. We can really visualize the topography of the area, if it's really hilly, etc. You know what I'm talking about really soon. So I'm just going to select hill shades. There's this really cool option. So for free, you can, guest users can download up to 50 million points. However, they don't have access to the personalized point cloud and raster jobs interface, which is called My Open Topo, which is just a wee cataloging system that saves the raster jobs and also gives you access to this really cool in-depth hydrological analysis. You can just click on a button and then you have a hydrologically correct DEM with pits filled. So if you had sparse LiDAR data that I was talking about and you want to create a DEM, you can use these additional tools that if you sign up to, all for free, really start exploring and learning from what value this data has to give. You just need to find a wee few bits and pieces and tools and software, and it's just a gold mine. So yeah, so you can use a topographic wetness index. So lots of bits and pieces there. Just put your email in and click submit. So if you're a registered user, you have access for each download. Each download, you have access to 250 million points, and also additional tools, etc. So I'm just going to demo some other resources that LINS has published. So there's this on location. So LINS has this on location medium blog site, and we have 3 elevation data Pacific blogs that have published. The second one, so the first one is about downloading point clouds of open topography. So what I've just demoed to you, there's a blog about it, and it will be in the wee summary sheet that we'll hand out to you at the end of this webinar. So the first blog is called Creating Point Cloud Visualizations. Just gives a rundown what we just talked about. And while we're waiting for the download to happen, so it's just creating the digital elevation model. Another really cool tool that Open Topography has is that they've incorporated a Poetry web viewer. So it's a little of a challenge at the moment to view these 3D point clouds just because they're so massive and so dense. They have used Poetry, Entwine, and Greyhound in the back end to be able to visualize billions of points. And it's a really cool exploratory tool for this type of data. So hopefully this is downloaded. Yep. Okay. So once this has been downloaded, it should look like this. So this is the older, oh no.
It's okay. It's okay.
It worked before.
Yes.
Damn it. I'll just use the images. So when you open this link, point cloud visualization. So when this is finished, you can click.
Do you want to come back to that?
Yeah.
I can do the rest of my bit, and then by then it might be ready.
I'll just wrap. Yeah. Thank you. Sorry.
Right. No, you just stay there. Okay, so I'll just grab the mic. Cool, thanks, mate. There's a couple of questions we'll come back to in just a moment. Just wanted to finish off this very quick demo now that I've signed into ArcGIS. It's been a few days since I logged in here. And so what I've done is nothing except for log in. I'm going to come over to my data folder, grab that link, come share my screen for a moment. Here we go. Okay, so here's my data. I'm going to grab that link. So I've done nothing further, absolute promise. All I did while Rose was on the case was to log into ArcGIS Pro and start it up and create a new map. So now I'm going to go and add some data. Add data to the map. I'm going to add it from that source. Here we go, not there, this one. There's my TIFF, add that. Waiting for it to load, here we go. Okay, and you can see because I downloaded that in WGS84, it's also done things to the map, and I'm going to go in here, properties, change that to, let's see what I've got here. That one will do. Go OK. Now, if I wanted to get into some real hydro stuff, then I can also set the vertical datum and other things as well. But you can see here, let's just turn off the base maps. We've got just a plain 1 meter DEM for Ohura. And I'm just going to hide this floating meta controls. And so next thing, I tested something like this on Friday. I've just got to find the right one, which is usually just by exploring. And I did it on a different computer, so none of this is going to come up. So this is quite a neat place if you've not had a play with this already. Neat place to have a to-do with. Lots of out-of-the-box tools. But the one we're going to have a quick look at is surface tools. So let's say we wanted to create a hillshade. Click that. And first thing, trap for young players, and I don't know how many times I've done this, is try and set it off against nothing. So you just choose the one that you're going to run it against. Hillshade type, we want a multi-directional because they're cooler. We don't need to worry about that for now for what we're doing, but there is the Z factor is to do with latitude and longitude. So we are using actually decimal degrees data, but I don't think it matters too much for now. But there are some tables online that you can look up for the Z vector adjustment if you want to get the if you want to fine tune some of that shading. So you can see there you've got a nice hill shade over that DEM, and then if I wanted to, I could add a bit of transparency to bring that through. I can swap around. Where are we going here? Appearance. And if I wanted to apply some, you can see there a bit of the DEM coming through. I can add some color in that to that as well if I wanted. I can add create view sheds if I wanted from here, but the one I wanted to just show was creating contours. So very, very simple stuff here. Contours from the DEM, not the hillshade, but the DEM. Some smoothing to it, yep. Contour lines, or quite often I'll want to get contour polygons, but contour lines for this time. Contour interval, let's say 5 meter contours, and we'll just take the defaults there for now. And then we have some nice contour lines. Now, of course, if I was going to do something with this data, I would read the metadata so that I knew all the ins and outs of working with it. And before I made this map public to anyone, I would go and add various disclaimers and things and make sure that I had assurance of what the data is representing. But there's just very simple, download the data, creating hillshades, creating contour lines. There's a bunch of other tools in here. Someone mentioned to me the other day their favorite thing to do, I think it was someone in the Topo team, is to take a DEM and take a DSM, the digital elevation model, take the digital surface model, and subtract from the two to be able to look at things like vegetation cover. Okay, so that was just a quick demo. Now, Rose, do you want to come back online? I'm going to hand this microphone over and show us, hopefully, the rest of OpenTopo.
I'll just double check that.
I'll just share your screen.
Yeah. So that download has finished. So just a quick summary of what's been happening. So I just went to opentopography.org, clicked on the data tab, clicked on the data catalogue, searched by New Zealand, decided to look at Wellington. Wellington City 2019 dataset is identity data. One of the cool options for downloading data through OpenTopography. So this is just the classified point clouds only. We published 3 deliverables, DEM, DSM, and classified point clouds. So this is the vector deliverable. this web viewer and the Entwine Greyhound backend software is really good at displaying millions and billions of points that would otherwise be eating up all your RAM on the computer. So we have lots and lots of different options. So we have really a really cool toolbox available in this Poetry web scene viewer. So if we want to identify which areas are buildings, we can symbolize the points by classification. So if you go into scene, under the scene option on the left-hand side, under the display attribute tab, you have lots of different options. Classification is the standard symbology for discrete aerial LiDAR data. As you can see here, this is the Wellington Botanic Gardens and the terrace. So you can see, here's the motorway, here's the terrace. You can just see how dense the data is. So this is just a small subsection of the data, and you can just zoom into your heart's content. So you want to have a wee snoop at the rose garden. Just go in, zoom, 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 zoom. If you're thinking, oh, there's way too many trees here, I want to see what the ground looks like underneath in Botanic Gardens. I had a wee walk around there the other day. I can filter the points, so I can remove the vegetation. So this is where LiDAR data really becomes a cool, so it shows its difference. So this is where it's just a little bit different to imagery in terms of just the dense, accurate information about, spatially accurate information about the surroundings, and the ability to strip all features between ground and the highest features. If that makes sense, let me know if I'm starting not to make sense. But we also have other options. We might have
to skip those ones for now so we can make sure we get John.
Oh, sorry. So have a wee look at it. You can use cost sections. There's this blog called Creating Point Cloud Visualizations Open Topography that covers everything. So yeah, that's me.
Cool. Thanks, Rose. We'll share some links to that as well in the document after. All right, John. Next, John is going to show us a collection of real-world applications. So just make sure you can access that. I think it's on the first tab if you're looking for that
yes.
list of links there, John.
Oops, the screen.
Just up a bit, I think. Well, you know what you're doing. Just click the blue there. Yeah, there we go.
Thanks, Dwayne. Thanks, guys. I'm just going to follow up some of the discussion with some examples of the work we've been doing at the Regional Council here in Wellington. And we've been acquiring LiDAR since about the year 2000, but it's really come of age for us since about 2013 when we did a consortium of local authorities and LINs assisted by Landcare Research. We captured the entire region, and we've received a lot of assistance with basically hosting and improving that data since. So it's been migrated up to NZVD16 in the past couple of years and put on Open Topography, which has been tremendous for us. I just wanted to give a few examples of how we've actually used this. Dwayne said something about the real world. I've always found the real world to be quite an elusive place most of my career, but perhaps I've arrived. Who knows? I'll just show one example. A major driver for us in terms of LiDAR acquisition was in flood modeling, floodplain modeling studies. Basically, it's essential for them to have really detailed LiDAR data as inputs to the model. And also, usefully, from a GIS point of view, there are the derived products, which You can see here Masterton in the Wairarapa and some of the very detailed flood models that are put out for the, I think the 1% AEP floods covering part of the city here. So that's our flood modeling, which has been, as I said, the initial driver and often provider of funding. A second major use of the data was in land management, and I'll just illustrate that through some of the topographic mapping products we've created. So if I zoom into an area here in the Wairarapa. Rose earlier alluded to how you can use LiDAR data for determining faults. This line here from southwest to northeast is in fact the trace of the Wairarapa fault, a major fault that last ruptured in 1855. This is a tile-cached map, and it illustrates a number of features that have been described earlier. For example, the detailed streams come from a hydrologically corrected DEM, which was then analyzed to define stream traces. Another thing that was mentioned by Rose was the how you can acquire vegetation height. This mottled green layer here is the tree canopy. It was referred to as a canopy height model, or CHM, and crudely speaking, it's a DSM minus a bare earth DEM with a little refinement to remove things like buildings and so forth. You can actually see from the colors the tree canopy height, and work has been done, for example, on analyzing where all the tall trees are within the region. Really useful for land management. You can do things like effective paddock area. You can see the gradients of the paddock. You can do lots of very detailed soil mapping with assistance from this kind of topographic data. You can also see the hillshades and the detailed contour data as well. So in this case, we've got 1 meter contours for this part of the land. And the final thing I wanted to touch on was its use in natural hazards. So if we are doing things like looking at tsunami mapping and also sea level rise mapping, this is actually an invaluable data set. That wasn't so good. I'll just, yeah. I did pick the most difficult place to spell in the region. So if I just zoom in. Here, we've used the bare earth LiDAR elevation surface to define a series of surfaces which represent potential areas of inundation during sea level rise. So if we just look at what happens during different levels of sea level rise, in this case, the village of Partanui is here, and there's also a major state highway 58, runs along the southern boundary. And this kind of detailed mapping can illustrate the risk posed by sea level rise inundation to infrastructure like major roads. We've got the development of the transmission gully motorway here at the very bottom end of the map. And also it's quite interesting from the point of view of inundation of wetlands and whether the wetlands can actually expand inland. So a multitude of uses for that data. Thanks.
Cool.
Right.
Thanks, John. That's fantastic, mate. I really like how you have made that data so accessible for the public, because for us GIS guys, you know, we often, or just people rather, we often spend all our time in this analysis, and then the presentation for public users is often left out. So that's fantastic. Also, the one that I really like is over in the Marlborough Sounds bathymetry, although it's not LiDAR. It's a similar kind of concept. It's a great way to make it accessible. Okay, so we're a bit short on time. So Rose was going to show us some R scripts and things, but what I suggest, Rose, is we leave those for now, and we will share that in the handout, those links.
Just quickly run through the blog.
Yeah, just put do you want to just put the link up, and then, yep, just come put the link up on here. And just while Rose is doing that, if there are any other questions, feel free to put them on the chat, or if you're after anybody you want to contact to talk further about something like Bjorn or John or Rose, just feel free to flick us an email. If you email either myself at dwilkins@lins.gvt, or and I can pass that on and they can come back to you. Handouts. So we are going to make the handout more accessible than its current form. We'll email it to you. Over to you, Rose.
So there's a question about, can someone explain a tin? So just going back to basics. So one of the options from downloading point cloud data from Open Topography is you can make your own digital elevation and surface models. In creating those rasters, there are two methodologies of doing that. One is a triangular irregular network methodology, and another one is a local grading binning system. Those are the two interpolation rasterization methods available to convert a point cloud to either a DEM, a DSM, or a DSM. So yeah, we have this blog that is on Medium. So if you Google search on location Medium, you will find these blogs. And there's also another one identifying trees using R in LiDAR data. So yeah, that's me.
Cool. I can grab that for a moment, guys. Just save me typing a couple of replies there. So Wade is after, we'll be emailing the link out probably later today for the document. Aroha Wade, the earlier Macron webinar, it took me a while to do the transcription for the captions. And of course, once I've done that, and then it was the weekend. So it's still on my to-do list and it will be coming. But in the meantime, if you do want to access that, it's on growgis.nz and you can access that there. Question also from Tim about Auckland 2016 point cloud available on Open Topo, but can't yet find a link to it on LDS.
The supplier, I'm
okay.
sorry, I just stood over John Gibson's foot. Apologize. The DEM is being currently being worked out by the supplier, but the point clouds have been published and the DSM will become available hopefully in the next week or two. So yeah, we're still waiting from the supplier for the DM. So apologies for that, but we're doing the best we can so far. And yeah, just a few bits and pieces that we found that are holding things up.
Cool. Thanks, Rose. Okay, well, just come and join us again, guys. Big thanks to everyone for joining us today, and hopefully there was something useful in there. I'm sorry we went a bit over time. My thanks to Bjorn, to Rose, and to John. Thanks for joining us today, guys. Really appreciate it.